The reflection of the point 1, 0 in the line y equals mx has coordinates one of these expressions. I mean, my first thought here is to kind of just not totally brute force things, but you know, if we drew a picture, drew this point, drew the line, dropped a perpendicular or an orthogonal projection, and then figured out how that works, that might that would get there. It might be pretty tedious, and I'm wondering if there is just an easier way to do this. You know, if we wanted to sort of not cheat, but use the options here, we could think about some specific values of m. You know, simple things like m equals 0 or 1, where it should be immediately obvious what the coordinate is, and maybe that would allow us to eliminate a bunch of options here. But I'd rather actually work through, or another thing we could do is look at some of these options and eliminate them based on some simple logic. You know, for example, option B is certainly incorrect because if you reflect a point through a line, you know, the first coordinate is certainly going to change. But I think I'd rather just try and work it out somehow. Do I really want to work this out? I'm you know, really not a fan of geometry type problems, but you know, we could maybe try and again, I don't want to just look at the options and deduce by the process of elimination which one it is. I'd rather try and derive this. You know, if we draw this line there, so this intersects at a right angle, and then continue that line for an equal distance. So it looks like we go up to about here. This is the point we're looking for. Okay, so here's what I might do. I'm going to find the equation of this straight line. That shouldn't be too easy. So first we know that the slope of that line is the negative reciprocal of the slope of the original line. So the original line here has a slope of m times x, or m, sorry. So the slope of the new line is negative 1 over m. And we need to solve for this intercept, which is, so I know this point, of course, is on the line. So we have that b is equal to 1 over m. So this point here is 0, 1 over m. So I could find also now the intersection between these two lines. So if I say that mx is equal to kx plus b, so this happens when x is equal to m squared plus 1. Sorry, 1 over m squared plus 1. And so what does that say y is equal to? Well, y is equal to mx, so y is equal to m over m squared plus 1. Okay. So what I'm going to do now is, I don't need that line, but I want to figure out the coordinates of this point by knowing that in going from here to here, I've gone half the distance that I need to go to get to there. And in going from here to here, I've gone half the distance that I need to go to there. So, I'll mark that point there. If I call that distance d, then this is also d. And I mark that there. I clearly didn't draw this to scale, but that's fine. I mark that h. Then this is also h. Okay, I hope this is one of the options that's given, because this is what I find the coordinates to be, and it is. This is option D. Yeah. Something is telling me that there's probably an easier way to figure this out, but this ended up working out. It was a little bit tedious, but nothing too difficult. Just figuring out the initial approach is what ended up taking a long time. You know, when I first read this question, I didn't think that I would be finding the equation for this line, and there's probably, again, you know, there's probably easier ways to figure out what that point is without figuring out this equation. And if you know this point, then you can easily find that point because you know you're just moving double the distance. Yeah, but ended up getting there in the end. So I guess I'm pretty confident this is the correct answer. Thanks for watching.